Alright, so we don't have to have just e. We need to look at what we would do, say, if we had maybe 5 to the x as a base, 5 as a base. There's got to be a way to take a derivative of this. And there is. And it's not too terribly complicated. You just have to remember a formula, basically, to take the derivative. But what does it mean as a logarithm to have a base other than e? We have a formula that we could use to change it over to a natural logarithm. If we have log base a, so some other base than e, remember natural log is log base e. If we have log base a of x, that's the same thing as 1 over the natural log of a times the natural log of x. Okay, so you can always rewrite, if you have a logarithm with a base other than e, you can always rewrite that in terms of natural log. But the formulas for the derivative of a base other than e, like let's say a to the x, is the natural log of a times a to the x. So the derivative is pretty simple. If you have a constant to a variable power of any type, then that would be a u. Let's think about it as a u. That's the best way to think about it. Then that's going to be equal to, the derivative of that is going to be equal to the natural log of a times a to the u times, what do you think? Du, right? Anytime you have a u, you're going to have a du, so times du. And with derivatives, remember, we multiply times the du. Okay, so for example, let's say I have y equals 5 to the 2x plus 3 power. Alright, if I want to find the first derivative, then my u is equal to 2x plus 3, which makes my du equal to 2. Now to take this first derivative, I need to follow my formula. So it's the natural log of the base, so the natural log of 5, that's a constant, times 5 to the 2x plus 3 power times the du. Alright, and so the best way to write this now would be 2 natural log of 5 times 5 to the 2x plus 3 power. Alright, so I guess the toughest part is just to remember the formula, but the formula it's almost the same, except, the only difference between the derivative of e to the u and a to the u, e to the u is just e to the u du. But a to the u, we just have this natural log of a in front. So it's not a real big difference.
Is that as far as you have to go with it?
That is as far as you would have to go if you need to take a derivative. Alright. The integral, think about it, going backwards very similarly. The integral of a to the x instead of having this natural log of a that you multiply in front when you take a derivative, you have a 1 over natural log of a, and that's times a to the x plus c. So how does this differ from the integral of e to the x? Well, the integral of e to the x is e to the x plus c. So the only difference is that you put a 1 over natural log of a as a constant coefficient. You know, you could even think about this integral. Could you think about this integral like it has this in front? 1 over natural log of e to the x plus c. You know, just to kind of relate it to what we already know. Because what would 1 over natural log of e? What's natural log of e equal to? Natural log of e, remember those are inverses. The answer is the power. So that would be 1 over 1 e to the x plus c. Or e to the x plus c. So the formula even works for e. It's just that we don't write all this. This is kind of hidden. We don't worry about all this. It's just easier to not have to remember that. But it's there. It's just hidden. All right. So one more time, quick review. To take the derivative of a base other than e. So instead of e to the u, we're taking the derivative of a to the u. You say natural log of a times a to the u du. And then most of the times this du, if it's a number, you want to write it in front. If it's more than one number, maybe it was x plus 2 was your du, you want to make sure you put it in parentheses in front. Okay. Integral. So the integral of a to the u simply be, well, it's a to the u, as long as you have your du, is 1 over natural log of a to the u plus c. Alright, so let's see if you can do this one. Integral of 2 to the x dx. So what's your constant that goes in front? 1 over natural log of 2, and then 2 to the x plus c. I mean, you can write your 2 to the x in the numerator, but that's acceptable to leave your answer just like that. So it's, I mean, they're almost the same thing as e to the x, except for the natural log part.